Hello everybody, welcome to the webinar today. We're here with John Harrison. He's the package author and maintainer of the RSelenium package, which can be used to test Shiny apps. So John's going to talk about that today, but before we get started, I just want to talk about some quick logistics information. So let's go ahead and cover that now. So you'll notice in the GoToWebinar control panel you have an orange button, and this button allows you to maximize and minimize your control panel. So when your control panel is maximized, you'll notice that you can have different options like audio type, for example. You can select microphone mode, speakers mode, also telephone mode if you're in the United States, but keep in mind, if you're in the United States, telephone mode may cost you some money. So be sure to close other applications that you may have open, things like Skype, LinkedIn, Facebook, Twitter, Gmail, that could take bandwidth. You can make my webinar screen larger. If you click a corner of my screen and drag it, you can make my desktop screen larger on your computer. And then if you have headphones, go ahead and plug them in. It'll make it easier for you to hear the presenter's voice. And, you know, iPod earbuds work great, for example. So let's go ahead and talk a little bit about myself. So my name's Ray DiGiacomo Jr., president of Orange County R User Group, and this webinar is brought to you by the Orange County R User Group. So I'm a healthcare predictive analytics consultant, and you can join Orange County R by visiting LinkedIn groups. So that's just a little bit about myself and the Orange County R User Group. This video is currently being recorded, so if you have any colleagues that were unable to make it today, we're going to record the video and distribute that to those in the audience. So you'll get an automatic email from GoToWebinar sometime today with a URL, and then we'll update that URL sometime within the next 7 days. So give us about 7 days to upload the video of today's session. So that's video. Just wanted to talk about upcoming R webinars. So on June 24th, I'm going to do a webinar on the new rough sets package, which is a package for rough set theory and fuzzy rough set theory. So you can register for that at liondatasystems.com/events. So that is it for my presentation. What I'm going to do now is I'm going to go ahead and turn things over to John, and I'm going to make John the presenter. So John, go ahead and show your screen when you're ready, and then we'll just do some quick tests. Okay, I can see your screen great. And just transition your slides back and forth really quick so we can see. Okay, the transitioning looks great. So John, go ahead and introduce yourself, and you have the floor.
Thank you, Ray. Welcome everyone to the RSelenium webinar. Firstly, I'd like to thank the Orange County R User Group for inviting me to give this presentation on the RSelenium package. I'd also like to thank Ray for taking the time to walk me through the GoToWebinar software, and indeed for providing a lot of help and advice on the material I'll be presenting for you today.
Very welcome.
I say today, it's actually midnight here in Thailand. I know we have people from many countries attending the webinar, so welcome again to everyone. So who am I? As Ray said, my name is John Harrison. I'm the author and the maintainer of the RSelenium package, and I've been using R since about 2000, so if my maths is right, that's 14 years. So here's a picture of me with my son Jack. I'm the fat one on the right, for anyone who's wondering. When Ray asked about a time for this webinar, midnight my time seemed ideal, as there was every chance that Jack, who's just turned 3, would be fast asleep. And hopefully he is fast asleep, otherwise we'll probably all know about it. So moving on, what is Selenium? So if you go to the Selenium homepage, that's http://seleniumhq.org, there's a one-line explanation of what Selenium is or what Selenium does. Selenium automates browsers is what they say. So the idea is that the Selenium software allows you to automate many different browsers. Another possible definition of Selenium is that Selenium is a set of tools for cross-platform automated testing of web applications. So that's a bit of a mouthful, but we have the idea that Selenium allows you to drive your browser on different operating systems, and one of the main uses of it is to test web applications. Selenium is also used to some extent for web scraping, and also for things like load testing and synthetic monitoring of web pages. So that would be looking at the time it takes for a page to load, and then looking at events such as the first paint time. So that's the first time we see the browser drawing something to the screen. So Selenium supports a number of browsers: Google Chrome, Mozilla Firefox, Safari from Apple, Microsoft Explorer, or Microsoft Internet Explorer, the headless browser PhantomJS, and a number of other browsers such as Opera and HTML-Unit. The Selenium standalone server runs on Windows. It runs on Macintosh, Linux. You can drive browsers on the Android platform. You can drive browsers on iOS, so that would be the iPhone and the iPad, and other operating systems such as the upcoming Firefox OS operating system from Mozilla. There's bindings in a number of languages. Officially, bindings produced by the Selenium project, there's 4. So there's Java, Python, Ruby, and JavaScript. On top of that, there's a number of third-party bindings for other languages such as PHP, Perl, C#, and of course R. So RSelenium is a third-party binding for Selenium. So why do we call it a set of tools? So it's actually composed of a number of projects. Originally we had the Selenium IDE and the Selenium Remote Control. So this is what we would refer to as Selenium 1.0. Later on came Selenium WebDriver and Selenium Grid, and that's what we now call Selenium 2.0. So basically, what we're interested in now is this Selenium 2.0, and specifically Selenium WebDriver. So the RSelenium package communicates with the Selenium WebDriver. So how does that work? Well, we can look at a picture. So pictorially, on your computer is running RSelenium. So RSelenium implements the API, which is called the JSON wire protocol, and that allows you to communicate with the Selenium WebDriver. The Selenium WebDriver in turn communicates with the browser, and the browser communicates with the website of the web app which you are interested in testing. Now, you'll notice that the Selenium WebDriver and the browser are contained in their own sort of box there. So that indicates that they're running on a separate machine. So they may be running on the same machine as RSelenium, or they may be running remotely. So RSelenium allows you to control a local or a remote version of the Selenium WebDriver. The Selenium WebDriver communicates with the browser through a particular binding, and each browser will have its own way of implementing the binding. Firefox and Safari, they both implement it in a similar fashion through a browser extension, whereas Chrome and Internet Explorer have a standalone executable that acts as a bridge between the browser and the Selenium WebDriver. Something like the PhantomJS project, there's a third project called GhostDriver, which allows the Selenium WebDriver to communicate with the PhantomJS browser. So again, we don't really have to worry about that. We just have to worry about communicating with the Selenium WebDriver. So that's what RSelenium does. It implements this API, which allows us to communicate with the Selenium WebDriver. So how about RSelenium? Well, as I say, it implements this JSON wire protocol. The project is hosted on GitHub, so I'm just going to bring up the project page just for you to have a look at. If you're not familiar with GitHub, you can watch a project there. So if you watch the RSelenium project, you'll be notified of any changes that occur to it. If you like the RSelenium project, you can star it. So it's a bit like on a social network where you have a +1 or a like button. And then also you can fork the project. So that means you can get your own copy of the RSelenium project on your own GitHub account and make changes to the code if you like, and perhaps even issue pull requests to me to fix some issues or bugs that you might find. So talking about issues, if there's any particular project problem you find with the RSelenium software, or there's some feature you'd like implemented, you can file an issue here on the GitHub RSelenium project page as well. Okay, RSelenium is also on CRAN, so if you go to the R project homepage and search for RSelenium, you'll find the project there. So that's all I'd really like to say about the RSelenium infrastructure for the moment. Just to start with, we're going to look at some basic operations. So we're going to look at how RSelenium operates in a basic fashion. We're going to look at initiating a browser using RSelenium. We're going to look at navigating, going backwards, forwards, refreshing the page, etc. We're going to look at interacting with the DOM. So the DOM is the document object model. So if you've got a HTML page, you can break it down into this document object model, and within this DOM there's elements, and we'll look at how we interact and pick out the elements from the DOM using RSelenium. The last basic operation we'll look at is frames and windows and how they relate to the RSelenium package. So, looking at browser initiation. I talked about this Selenium WebDriver, this standalone server. So we assume this is running when we use the RSelenium library. There is a utility function in the RSelenium library called start server, which will start this Selenium WebDriver for you. There's also a utility function called check for server, which will download it from the Selenium project homepage if you don't have it on your computer. But we assume the Selenium WebDriver is running. We're also required to load the library, so we can do that using the library command or require. Once we've done that, the structure of RSelenium is quite simple. There's 3 reference classes. There's an error handling reference class, there's a remote driver reference class, and there's a web element reference class. The web element reference class contains the remote driver class, or inherits from the remote driver class, and the remote driver class inherits from the error handling class. So each of these particular reference classes will have methods. All of the methods are available to the web element class because it inherits from both the other 2 classes. The remote driver class has its own methods plus the error handling methods, and the error handling methods just has its own methods. How do we call the remote driver class? Well, it has a number of arguments, such as browser name. By default, the Firefox browser is used. So if we don't give any browser name, RSelenium assumes we want the Firefox browser. I said that the Selenium WebDriver could be remote or local. If it's remote, we need an IP address, so we have a remote server address and possibly a port. By default, the port is set to 4444. If it's something different than that, we have a port argument we can call. Once we've given the arguments to the remote driver class, we can use the open method, which will actually instantiate or open the browser. And there's an optional argument with silent equals true, so we won't get any output printed if we want silent equal to true. Once we've gone ahead and initiated a browser, then we can go ahead and navigate and continue using the RSelenium package. The little table below is just some statistics that I collected. So one of the pages associated with the RSelenium project has a Google Analytics script, and that just gives some nice statistics on the, for example, the browsers that people that are interested in the RSelenium project are using. So this was over a period of time. We looked at what browsers we saw. So primarily people were using the Google Chrome browser and Firefox, and a smaller percentage of people were using Safari and Internet Explorer. So that's the basics. What I'd like to do now is just to show you some code. So I'm going to be using the RStudio IDE. I said that we needed a Selenium server running. I'm going to run mine using the command line. So within my documents folder on this Windows computer, I have a copy of the Selenium standalone server, and I'm just going to run that by issuing a java -jar command. So now I have my Selenium server up and running. The next thing I need to do is to load my library, so I'll load my package. So I do library RSelenium, and then I said I needed to call the remote driver class. Now, I don't need to give a browser name if I want to use the Firefox browser, but I will, just so you can see how that would work. So, firstly, we're going to look at initiating a Firefox browser. So now we need to call the open method. I'm not going to issue silent equals true, so we will see output, which is called the session info. When we use the open method, we can see that a call is made to the Selenium standalone server, the Selenium WebDriver, and we're asking to create a new session with some particular capabilities. So you can see, for example, the browser name is equal to Firefox. I'm going to snap the Firefox browser to the right now, and I'm just going to give an example of navigating. So we're going to navigate to the CNN homepage, or the CNN News website. So here you can see the RSelenium package driving the Firefox browser through the Selenium WebDriver. And there you go. So we'll just wait for that to finish loading. Okay. So very simple. Now we're going to close it down. We have a close method to close a particular browser. It's as simple as that. The next browser we're going to look at is Safari from Apple. So this will be the second browser. Again, we use the open method. Safari browser, very quick to open there. And this time we're going to navigate to the BBC website. So bbc.co.uk. Okay, all works nicely. Again, we can close that browser. And then just the final browser in this section we're going to look at is the Phantom.js headless browser. It's headless because it doesn't write anything to screen. Everything is done in memory. So that doesn't sound very useful, but it's very fast. So we use the browser name Phantom.js to open a Phantom.js browser, and again we use the open method. We're not going to see anything, but we can still navigate to web pages. So let's navigate to the Google homepage. So that's google.com/ncr. So this is a country non-specific version of the Google homepage. We don't see anything, but we have this nice method which is called the screenshot method, and it allows us to take a screenshot from any browser. If we're in the RStudio IDE, the screenshot will appear on the viewer pane. So to the right, you should see the screenshot from the Phantom.js browser appearing on the RStudio IDE viewer pane. So it's quite a nice feature. Again, we can just quickly close down the Phantom.js browser using the close method. So that's us done with the browser initiation, the first basic operation. What we're going to look at now, well, we're going to look at navigating, and we haven't seen the Google Chrome browser, and we saw from our statistics that the Google Chrome browser was actually the most popular browser. So let's give that a viewing. So to open Chrome, we just give browser name equal to Chrome. Again, we use the open method. We're going to navigate to the BBC web page, then on to Google, and then we're going to see the go back, go forward method, all very basic. So as I say, firstly we're going to go to BBC. So this is the RSelenium software driving the Google Chrome browser through the Selenium WebDriver standalone server. It's a bit of a mouthful, but there you go. And as I say, we're going to go on to Google now. So we have two websites. Now we can go backwards and forwards. I said the remote driver class has a go back method. So we're going to go back to the BBC website, and then we're going to go forward again. So this is just basic navigation. Once we've done that, we're going to refresh the page. So the page is actually refreshing here. It doesn't look like it's doing anything, but you can see it's popping up on the toolbar. The next thing we're going to look at is cookies. Google is kind enough to give us some cookies, so we can get all cookies and see what Google's imparting to us. So you can see that we get a list, and it looks like we have 2 cookies. If we look at the length of this list that we're returned from the get all cookies method, we've got 2 cookies. So what we're going to do is to look at the name of the particular cookies. So you can see we have a cookie called NID and a cookie called prep. We can delete a cookie if we want to. There's a delete cookie method. We have to give it a name. So let's delete the NID cookie. Now if we call our cookies get all cookies method, we'll see that we're only given the 1 cookie. If we needed to, we could also add a cookie. So there's an add cookie method, and you can see that it takes a name, a value, a path, a domain, and an optional secure argument. Finally, there's a get status method. So get status returns us some information about the operating system that we're running. So you can see I'm running a 64-bit Windows 8 with a particular version of Java. This build version is related to the Selenium WebDriver, so I'm running Selenium WebDriver 2.4.1.0. And that's us done with navigating. The next important topic is interacting with a DOM, or the document object model. So RSelenium has a number of methods of finding elements in the document object model. 2 of the methods are specific to anchor elements. So what's an anchor element? If you look at your HTML source and you see an A tag, that's an anchor element. It's a piece of text which marks the beginning and or end of a hypertext link. So what methods, what particular options do we have when we're searching for elements? We can search by ID, by class, by what's known as CSS selector. So if you have used the jQuery library from JavaScript, you'll know the power of CSS selectors. There's also actually a very nice R package called Select R, which allows you to use CSS selectors as well. You can search by name, by tag name. So the anchor text has an A tag. Speaking of anchor text, you can search anchors by link text and by partial link text. Actually, looking here, I've actually forgot to write the most important method, and it's actually the default method that RSelenium uses to search for elements in the DOM, and that's XPath. So you can use XPath to search the DOM as well. I'm not going to give you explicit examples of searching the DOM because later when we look at some of the Shiny examples, we'll be using the methods anyway. So we're just going to move on now to the final basic operation topic, which is frames and windows. Basically, RSelenium has 2 methods. You can switch to frames and switch to windows, and then there's various other methods associated with the 2 methods. So you can get the Windows handles, you can get the current window handle, and so on and so forth. Easiest way to explain it is possibly by way of example. So we've still got our Google Chrome browser up. Let's navigate to the R project homepage. So that is http www.r-project.org. The R project is an example of a web page that uses frames. It should have 3 frames, one for the logo, one for the sidebar, and one for the main panel. Now the remote driver class has a getPageSource method. That enables us to get the HTML source of the web page that we're viewing. It doesn't look very presentable. What we can do is we can call the HTML parse function from the XML library, and now it looks a bit more readable. So you can see we've got 3 frames here. We have this logo.html frame, which is the logo frame. We have this navbar.html frame, which is this contents frame. And then we have this main HTML frame, which is this banner, what they give a name of banner, where the main content is. I talked about having 3 reference classes. I talked about the arrow handling class, the remote driver class, and the web elements class. When we search the DOM and find some elements, they are returned as a web element reference class. How do we get those web elements? Well, we're going to see now how we get all the frames on this page. So there's 2 methods that the remote driver class has. You can find element or find elements. So singular or plural. So of course we want to find all the frames. So we're going to use the find elements method. I'm going to search using CSS selectors. And it's very simple. I just want to find the frame. So that should do us. So we should return 3 reference classes, 1 for each particular frame. So if we look at the length of this web elements object, it should have length 3. That is worrying. So for some reason it's not been able to find the elements using CSS selectors. Oh, it does help if you actually write CSS selector rather than selectors. So let's try that again. And now we have an object of length 3. Sorry folks, I was getting slightly concerned there. And if we look at the first element, we can see that we're returned a reference class. This is actually just the bespoke show method that Web Elements reference class has. We have nice utility method, a nice utility method called the highlight element method. So let's highlight the first frame. There you go, you get a nice visual representation. If you're worried about whether you picked the right frame or not. So we're going to highlight all the frames. So there you go. There's an example of frames. We can switch to a particular frame. The switch to frame method takes a reference class, a Web Elements reference class. So we can switch to the second frame, which is this sidebar, just by passing in the second web element. And now when we ask for the HTML source page, we should see the HTML source page of the sidebar. So you can see there we have all the various links. So that's all I'm going to say about frames. If we opened a new window, we could control that using the switch to Windows method in a similar fashion. Windows have IDs, so we can get the current window handle, and we can see this particular window has a particular ID. So when we open a new window, we'll get another ID which will allow us to switch between various windows. So that's all I'm going to say now about basic operation. I'm going to move on to JavaScript. Well, I'm going to move on to some advanced operations. The first advanced operation I had in mind was JavaScript. I'm going to leave that till the end because the other 3, interacting with Shiny apps, remote driving, and external providers, sort of flow together. And if we have time at the end, we'll look at the JavaScript example I had ready for you. So we're going to skip the JavaScript example for now and hopefully come back to it at the end. Now we're going to interact with a Shiny application. I'm going to use the Shiny test app that comes with the RSelenium package. I have a copy of it running on the RStudio Spark server. So you can see the web address here. So I'm just going to copy that web address and call it app URL. I'm going to copy that to our RStudio IDE. So let's just have a quick look at what the Shiny Test App does. It's got some checkboxes. When we tick checkbox, various output panels pop up. What we're going to do, try to do now is we're going to try to write a simple function that checks whether all the boxes are ticked, and if a box is ticked, it checks whether the output panel exists or not. So a very simple test. How would we do that? Well, let's just open Firebug and have a look at the div that's containing these control panels. We can see that we have an ID control select. So let's go ahead and copy that ID and put it here. It's an ID, so using CSS selectors we'd use this hash to search for it. We're interested in each of the checkboxes, so each checkbox has a span element. So we're looking for an ID with control select with child elements which are spans. So this is going to be our selector, our CSS selector that we're interested in using. So we're going to try to write a function. So let's just explicitly write test app script. Let's call our function test app script. So let's just say it's a function which gets a remote driver. For now, we'll just have one argument to our function. So the first thing we want to do is, we're going to pass it a remote driver class, but it's not going to be open. So the first thing we want to do is open our remote driver class. Now, we could use a on.exit close method, but we'll just keep it simple and call the close method at the end of the function. Now we need to write some content in between. So we're going to tell RSelenium to wait if it doesn't see a particular element in the DOM straight away. So we're going to have an argument wait. We're going to set an implicit wait timeout, and this is going to be in thousands of seconds, but we don't want to give it in thousands of seconds. We want to give it in seconds. So we're going to have wait times 1,000, and so this is waiting for elements in the DOM. And then we want to navigate to our app. So we're going to navigate to whatever particular URL our app is on. So we better have a third argument which gives the app URL. Okay, now the first thing I want to do in this test function is to highlight the particular checkboxes, just so we have a visual indication that we have selected the right boxes. So first of all, we want to select the elements. So we're going to use the find elements method. Again, we're going to use the CSS selector, and I'm going to spell it correctly this time. And we've already formed our selector. So we're getting all the span, the children, which are span elements from this div, which has an ID of control select. So firstly, let's put a sleep in there. So let's sleep for 2 seconds. Then let's highlight the elements. So each element, we're going to highlight it by calling the highlight element method from the remote driver class. Now, let's quickly test our script with a vanilla Firefox browser. So let's just say our wait is 2 seconds. So we're opening the Firefox browser now, and we're navigating to our Shiny app. Now we're going to check that we have the right elements by highlighting them, and we do. Okay, so we're good to go again. So what's the next thing we want to do? Well, for each checkbox, we want to check whether it ticked or not. So let's just put another sleep in here. Each element, each checkbox, when we ticked it, had an output panel. We need to check for the existence of these output panels. How would we do that? Well, we'll check them by their ID. So you can see that the first panel has an ID equal to summary. The second panel has an ID equal to distplot. The third panel has an ID equal to ggplot. And the final panel has an ID equal to ddtable. So we're just going to remember those. We're going to call them, let's call them app IDs. And that's going to be a column, a vector of strings. So what was the first one? Summary. The second one was distplot. The third one was ggplot. And then finally we had dtable, I think. So those are the output IDs. Let's just assume we had element X. If we had element X, how would we select it? How would we check if it was selected or not? Well, let's look at our first element. So web elements 1. We have an isElement selected method. So that should return us a Boolean telling us whether it's selected or not. And you can see that it's returning false because it's not selected. So this isElementSelected method is going to be useful for us. So let's use that. We're going to use it for element X rather than 1. So we're going to have an if statement. If our element is not selected, so we need a not. We want to do something. What do we want to do? Well, if our element is not selected, we want to click it and select it. So we have a clickElements method, which we can see on element 1, how that operates. You can see when we click the element, it goes ahead and clicks it, and the output pane shows up. So if element X is not selected, go ahead and click it. Then test for the output. How do we test for the output? Well, we can use the findElement method. So we're finding a single element. We're searching using ID. And we want to search using the ID that's associated with a particular checkbox. So that would be app IDs X. So how would that work? Well, let's replace X by 1. One second. And let's highlight the resulting element. And you can see that it does do what we want. So it seems to be doing what we want. So now, finally, we want to highlight this output element just as a visual indication that, yes, we have selected the right element. And then again, we just want to put a sleep method. So sleep for 2 seconds. Now I think that is everything we need. So we've written our first simple test. So it looks good. So we can go ahead and use it. So let's close down this browser and see what would happen if we use it in anger, as it were. So let's call a new remote driver. And we're going to source in our script. Now, all we have to do to run this script is to pass it a remote driver, pass it some waiting time in seconds, and pass it a particular URL. So does it work? So we're passing it the remote driver class we've just created. We're going to wait for, let's wait for 10 seconds. That doesn't mean it will wait for 10 seconds. It means it will wait for a maximum of 10 seconds to find an element that's not present in the document object model. And let's run that. We're going to close it down and just see what happens. Okay, so it's opening our browser correctly. It's navigating to the correct web page. It should now highlight the checkboxes, and now it should begin selecting the checkboxes. Okay, it's not selecting the checkboxes for some reason. Oh, the joys of live testing. So here we go. Object X not found. It's a slight error in our code. I'm a very silly man. I meant to put this in a lapply, of course, and I meant to apply it along the web elements. And of course, we can indent the code, and it sort of looks all right now. So fingers crossed, let's try it again. Let's close down that browser we created. Source our script in again. 1, 2, 3, fingers crossed, close everything down. See what happens. Okay, so our browser's opening. We're navigating to the correct page. It's exciting. Okay, it's got to where it got before. Hopefully it will start selecting elements now. Oh, there you go. And yep. So it's highlighting the panels. And now it should close down. Fantastic. So we've written our first little test, and it was very simple, and it was done under a slight bit of pressure in a live sort of situation. So I'm very happy with that. So you can see now how powerful the RSelenium software can be. We have all these different browsers and operating systems that we can test. We don't actually want to run these Selenium servers ourselves, really. We'd prefer somebody else did all the maintenance. So next I'm going to look at remote Selenium servers. So how am I going to do that? Well, I have a remote Selenium server set up. If you go to my blog, there's a nice article on how to set up RStudio and Shiny Server on DigitalOcean. So in Singapore now I have a server set up which is running Selenium server, and I'm going to, so it's on this IP address. So you can check here, this is my RStudio. I've already started the server. We can check if a server is started by going to the port 444 and going to WD for WebDriver /hub. And if a Selenium server is running, we should see a splash page coming up. So there is a Selenium server running on this server in Singapore. Now, I'm just going to copy this code. I'm going to copy this code to my, so let's copy it here to my IDE. Now, because we're running a Phantom.js browser, again, it's headless, so we don't see anything. So let's see if we can get this interaction going with this server in Singapore. So I'm going to navigate to this web page, whatismyipaddress.com. And I'm hoping that will sort of tell us something about the server that's initiated that navigation. So let's display the screenshot as we did before. And you can see that this website tells us that the call for this navigation came from this IP address. So it's not coming from me. It's coming from this server in Singapore. So that's a simple. That's how simple it is to run a remote server using RSelenium. Very straightforward. The final topic before hopefully we get on to looking at some JavaScript is we're going to look at external providers. So the external provider I use is called Source Labs, and it allows you, it manages all these Selenium servers for you. You don't have to do anything. We've already written our nice little function. So you can see here there's a bit of legwork in setting up the remote driver to start with. So I'm just going to go ahead and open a new R script. So as I said, there's a little bit of legwork in setting up the remote driver initially. You need to give a username, a password, and a port, and then you paste these together to create your IP address. You need to tell it what browser you'd like to use, and you also need to tell it what version of the browser and what operating system you want to use. Then you can give it tags and various other things. So we're going to say R, so Orange County R user group test 1. I need a password. So let's go back to my Source Labs account and get my access key. We're going to run all this. We've already written our nice function, which was called test app script. We have a new remote driver which calls the Source Lab Selenium server, so we'll pass that into our test app script. We're going to wait for 10 seconds again, and the URL is as before. And we don't have to do anything else. What we can do now, we won't see anything on our screen. What we can do now is check out on the Source Labs page. We have our test running. And if we wanted to, we could actually look at that test running as it's going on. It will take about a minute to run. And if we wanted to, we could step into that test. So the Source Labs project is really nice. For every command we issue, it gives us a screenshot. It gives us a video we can look at afterwards. It gives us all sorts of logs. So it's quite powerful for testing. So once it's finished, we'll see the output. Again, hopefully it's just running through what we did before. Each particular step will get a nice screenshot, hopefully. So we'll just wait for it to finish now. This is the way I would do it myself personally. I wouldn't manage my own Selenium servers. I'd use an external provider. And it's finished now. So it's ran that test we defined, that test app script, and it should look familiar, hopefully. So you can see, first of all, it goes to the Shiny test app. So we should see the Spark Studio website. It starts looking for elements. It starts the highlighting. We can look at a video if you like. I don't know how this will come across. Yeah, so basically it's as simple as that. What I'd like to do now while we're waiting is just to run a whole series of browsers. So we could run a whole series of browsers. And hopefully we'll go back to that. So this is called test app script. Hopefully we'll go back to that once it's finished running, or you can look at it later. So we're going to test 3 operating systems, Mac, Windows, and Linux, and we're going to test various browsers on each operating system. It's going to do that now automatically with that little test script we've written, and we can come and look at that a bit later on. So possibly I'm finished now, right? I don't know if we'll have time for the JavaScript section.
We have
some
8 minutes until the top of the hour. I think we can go over a little bit. Would you like to start Q&A? How long is the Java session planned for?
I don't think we'll get time to run it. I'll produce a little video and put it on with the
Sure.
video from here as well. So,
yeah, you could just put it on your YouTube page next to this video of this webinar.
I will do, yeah.
All right, so would you like to start Q&A now, John?
Yep.
Okay.
Absolutely.
So we're going to start Q&A now, everybody. And if you have a question, go ahead and send it through the questions pane in the GoToWebinar control panel, and then click the send button. So what we'll do is we'll start the Q&A period now. So John, can you explain further on how to use a Firefox profile with RSelenium?
Right. Firefox profile. Okay. So let's open a second R because our studio R is a bit busy. So let's open a GUI and let's source the RSelenium project. We already have a Selenium server running, so we don't have to worry about that. How do we use a Firefox profile? Well, there is a utility function which is called getFirefoxProfile, and it takes a directory. So in my documents folder, I have a directory of Firefox profiles. So I have a directory of Firefox profiles. So let me just check what my working directory is here. Okay, so I'm not in my documents folder. So we can use this get Firefox profile method. And as I say, in my documents folder, I have a Firefox profile folder, and I have, for example, I have a Firefox profile that uses Firebug, so it's called Firebug Prof. Now, what happens, and then in Windows we need to use this use base equals true. What happens is that directory zipped up and it's base64 encoded, and that base64 encoding is sent to the standalone Selenium server. So now we can start a remote browser. We're going to start a Firefox remote browser, and we're going to have this extra capabilities argument, and it's going to be given this fprof, this output of the get Firefox profile function, this utility function. Now, hopefully, when we open the resulting Firefox browser, it should use the profile that we sourced in. That profile has the Firebug extension in it. So if it's worked, we should be able to use Firebug within this. Sorry, I've just closed that down. We should be able to use Firebug within this Firefox browser. So that's great. So any particular profile, all your bookmarks, all your extensions that you use, they're all available to you if you want. And we have a similar method with Google Chrome as well. So you can see there the Firebug profile is there. Yeah. So that's how we do that, Ray. We use this get Firefox profile method.
Great.
I hope that answers the
Yeah. Thank you. Can you talk a little bit about saving images?
Saving images. Yeah, sure. Right. So let's open a browser again, and let's navigate to the BBC website. So I said we can, with any browser, we can take a screenshot. When we take a screenshot and we don't display it, we're actually returned a base64 encoded PNG. So we can assign that to a variable. And I guess we can write the bin. So let's just write this PNG to a file, which let's just say, let's go to my documents folder. Sorry, our GUI is a little bit tricky. And so my PNG.png. So write in it's probably slightly more complicated than that. I'll get back to you on that. I'll add a little section on the JavaScript video on that. But yeah, it's basically as simple as writing that base64 encoded. Actually, I think we probably need to decode that first. Yeah, I'll write a little section on that and add it to that video.
Okay. And I think we have time for one more question here. So can you run Chrome with a Chrome profile?
Can you run Chrome with a Chrome profile? Yes, you can. It's slightly involved. Yeah, the answer is yes, you can.
Okay.
There are about 200 or 300 different arguments you can pass to the Chrome browser. Off the top of my head, I don't know what the argument is. It's something like use data directory. So what you'd have to say is use data directory and give the Chrome profile directory, and then you'd also have to stipulate the particular profile you were interested in. So there'd be 2 arguments. Off the top of my head, I don't know what they are, but yeah, I'll add that on the end of that video.
Sure, sure.
So yes, you can use a Chrome profile as well.
Okay.
It is slightly involved.
Well, great. So that brings us to the top of the hour, and I'd like to thank John Harrison for a great presentation. I just wanted to remind everybody that we're going to be doing another webinar pretty soon on the rough sets R package. So you can register for that at the site that was sent through the chat window. John, do you have any parting words for the audience?
Yeah, just if you want to see all those tests that we were running, I said we were testing all these different operating systems. You can see all those tests on sourcelabs.com/u/RSelenium0. They're all running now, and they're almost finished. So there'll be video and screenshots from that test we produced, and hopefully that will show the power of this particular style of testing. So we've written a simple script, and we've managed to test it on 3 operating systems, various browsers, all in the space of about 35 minutes. So hopefully that will give you an idea of what you can do with the package. So thanks a lot, Ray, and
Sure.
Orange County, our user group.
Yeah, thank you. So we're going to upload this video to the site. Everybody in the audience will get an automatic email with a URL within the next couple of hours from now. And so I'd like to thank everybody for attending, and everybody out there have a good morning, afternoon, or evening, wherever you are. And hope to see you next time. So have a good one.